Hello everybody, this is Tom from everystepcalculus.com, everystepphysics.com. Another partial fraction decomposition problem. I wanted to put this on because this is a single number in the numerator, and these all have different techniques. When you factor the denominator, anytime you factor the denominator, you're going to do partial fraction decomposition if that's it, if you can factor the denominator, okay? So remember that. And then, of course, you have different systems of integration and stuff, which I'll show you how to do with my programs, of course. You'd have to study it and memorize it yourself without my programs, and hope that something like this would be on the test. Maybe it would, maybe it wouldn't, who knows, So anyways, my emulator went off. So let's do it. You put index 8 with open and closed parentheses, which tells the calculator that you want to do a program. And this is all discussed and shown in my instructions and when you buy my programs. And then you download them, and then you get all the instructions on how to do it. And in your calculator is almost 1,000 programs now to handle any calculus problem, and certainly you're going to pass any test with my calculator, forever, not just for this semester, but I mean once you put them in here, you're not going to get rid of the calculator. If you do, you make more money because my programs are in there, but on eBay. But why sell that? You're going to have kids of your own that are going to take calculus. You're going to have a spouse or a partner that'll take calculus because they want to upgrade their job or whatever. Grandkids. You'd never get rid of this calculator, ever. It's one of the greatest calculators ever. So why would you get rid of it? Anyways, index 8, to get to my menu, you press enter, and up comes the menu. I already have it here at partial fraction decomposition, partial fractions, so that it's quicker for the video, not wasting so much time. But you'd scroll with this, up and down the menu when it comes. It starts at the A's, of course, and then you'll scroll down to this here, which is fast. When you get them loaded in your calculator, press enter, and I'll show you that we're in the program. And you're supposed to enter the function here. You enter the function by pressing alpha, and then you press each character as you go. Alpha 9 divided by x to the 4th power and stuff. The reason I'm not doing it here is because I don't want the emulator to screw up, and I've already programmed it into the entry line here, just like you would if you did your menu, and like I just showed you, you'd enter this and press alpha first on all my program when you enter anything, these lines here, okay? So here's what you've entered now. 9 divided by x to the 4th hx squared plus 16. Okay? Now that factors to this right here. And so I show you that you've entered the correct amount, and so you say okay. If you want to change it, you go back to change, scroll to change, and then I do the factor for you. That's not easy either, factoring, Could you factor this quickly? I don't know, maybe you could. Anyways, the calculator does it for me. And so we press enter, and we're getting the actual program. When it says here, it's trying to find the program and run, Now this is the first time I've just put it in here, slow the time, but after them in, it goes very quickly, And so we're going to set up the problem. We're going to multiply the denominators with the left side and the right side. And you write this on your paper, small, leave some out if you want, but generally when I research this, I have to do it this way to show you exactly how to do it step by step. So here's the 9 multiplied times the denominator, and the idea is to isolate the 9. So that's the reason you're multiplying times the denominator, which is the same. So then you eliminated. That's what the object of it is. And then you're going to create the partial fractions on the other side. And that turns out to be, and you're going to multiply the other side times this 2 times the denominator here. Okay? And you have ax plus b and cx plus d. We're going to eliminate the denominator. So for ax plus b, when we multiply this out and do algebra to eliminate one or more of the functions up here, we turn out to get ax plus b times x squared plus 4. That's what you're after. And then the cx plus d, since you eliminate, they're both the same, so then that is totally eliminated, cx plus d. So then you mark this down, x plus b times x squared plus 4 plus cx plus d. Okay, think of the guy who invented this. It wasn't Newton, but I mean, think of who sat around thinking about this and talk about being smart in math. That's for sure. So now we're going to multiply the ax plus b times x squared plus 4, which we got. Okay, and we're going to use the FOIL mesh. Remember the first, outside, inside, and last method, which you learned in algebra. So we do that, and we come up with ax cubed plus 4ax plus bx squared plus 4b plus cx plus d. Okay. Now we can combine those terms. We get ax cubed plus bx squared plus 4a plus c times x plus 4b plus d. Now we equate the coefficients of the left and at the right. Okay, so obviously the coefficient is 0 for x cubed, right? There's no x cubed on that side, it's 0 anyways. So then a must be equal to 0. Okay, same thing with the x squared portion. 0x squared is equal to bx squared. B must be equal to 0 then. 0x is 4a plus c times x, so 4a plus c must equal 0. Well, then you can sub in the a, which is 0, and you're going to come up with c equals 0. And then d, you're going to you got 9 for the last term of the numerator, right? And right here's the 9 of the last term of it. Here's 4b plus d. Okay, so then we sub in 0 for b, which turns out to be 0, and we got 0 here. And so then, no, d is here. So then d is equal to 9, right? Okay, so that's what we found. Now there's the original partials that we found, x plus b over x squared plus 4, etc. And then we're going to sub in the value for 9 here. That's the only one we have for the numerator. And we're going to integrate. We're going to integrate 9 divided by x squared plus 4 squared. Okay. Constant out of the integral all the time. And we have 1 over x squared plus 4 squared dx. Okay, so that requires a reduction formula. You remember that, huh? You've learned that on page 1030 or something, whatever it is in the calculus book. And here's the formula. Isn't that fun? Look at this formula. Yep, that's what you got to memorize if you're going to do this problem. And then you're going to substitute for a and u in here. Here's a's and u's, okay? You're going to substitute. I show you how you get that. A squared equals 4, so a equals 2. U squared equals x squared, so u equals x, n equals 2. All right, so that's what we found. We substitute all that in here. Write this all in your paper. Simplify as much as we can. And we have to integrate the integral that is embedded in the formula. We're going to use u substitution for that. Here's again what we figured out. So we have 9/8 times 1 over a squared u squared. got to integrate. The integral answer is 9/16 over tangent minus 1 x over 2 plus c. That's a identity type of situation for the embedded integral. And here's the answer here. So the answer is 9/8 x squared plus 4, 9/16 tangent minus 1 plus c. So anyways, that's a pretty complicated problem, but I wanted to do it just to make sure, because once I do it, getting into single numbers, then it's all programmed. I don't have to do it again. And you don't have to do it either if you buy my programs. The next thing is just to not have a 9 up here, but to have an x up here. Simple things like that I try to get for you. Then the next one would be 7x, and then with a coefficient in front. So anyways, good luck in your classes, and buy my programs and pass calculus. I help you all I can too. You can call me and I'll help you with calculus or the programs, whatever you needed. Okay, have a good one.